Miss Marion here. We're going to go ahead and do Unit 7, Lesson 7. So get out a piece of paper, and we're going to go ahead and go through some starter questions. Again, these are review to get us ready for the end of level tests. So go ahead and pause, go through this, and then come back to me. All right, so remember that in these kind of things, let's change that color. The letter next to the X is always the slope. And the number at the end is always the y-intercept. And the y-intercept is going to be -1. That's why I squared that whole thing. Number 2, let's find our slope. So remember that our slope is our vertical over horizontal. And it's the change of the vertical over the change of horizontal. Remember that we have an x, comma, y. And we normally subtract the numbers. So we're going to say 1 subtract 2. So notice we have 1 subtract 2. And then we're going to do the same pattern with our y's. We're going to go -3 subtract -17. And let's go ahead and get our calculators. Let's go ahead and figure out what that is. So 1 subtract 2 is -1 divided by 3 subtract a -17, put in exactly how it looks, and we're going to have 20. So our slope is -1 over 20. Now let's go into solving equations. Remember, if we want to go ahead, we want letters on one side, numbers on the other. So we're going to go ahead and add 17 to both sides, and then we're going to say 6 plus 7, that is 13. So our x is going to equal 13. Because positive and negative 7s make a 0. And then on number 4, we want to go ahead and our first step is going to be the distributive property. So 6 times v is 6v, subtract 6 times 7, which is 42. We still have our 5 and our equals. So remember, we want to get all of the numbers on one side and our letters on the other. So I see a subtract 42, so I'm going to add 42 to both sides. We're going to have 6v, positive negative 42, they go away. 5 plus 42 is 47. 6 and v, they are multiplying, so we're going to divide by 6 on both sides. 47 divided by 6. If we're doing decimals, it's going to be 7.83 repeated. So we're just going to do it as 7.83. And then we, fraction-wise, we can have the 47 over 6. We can also have it as 7 and 5 over 6 as fraction-wise. So all of these, that's v, not x. So all of these can be the answer for number 4. Number 5, again, we want to get variables on one side, numbers on the other. So I'm going to move my 4a to be over here. So I'm going to go ahead and subtract off 4a from both sides. Still have -3, positive 1a equals, and then -10. And then I want, again, letters on one side, numbers on the other. So I'm going to add 13 to both sides. So 1a equals a -7, or a equals -7. So let's go ahead and turn to page 129 in our workbook. Let's read the I can statements for lesson 7. I can change an expression with a negative exponent into an equivalent expression with a positive exponent. And I can choose an appropriate exponent rule to rewrite an expression to have a single exponent. So these are things, this is what we're going to be doing today. Give yourself a sentence, one I don't, about it, and then give yourself a number. 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. All right, let's go ahead and turn to page 53. We are going to look at all of these exponents and answer the question, which one doesn't belong. So you're going to write down blank, doesn't belong because, and then give a reason for that. So go ahead and pause and answer that, and then come back to me. So we can have different reasons as far as different things doesn't belong. We say the first one doesn't belong because both the numbers are 2. All the other ones are different. This one doesn't belong because it has a negative exponent. This one doesn't belong because it's multiplied with a negative exponent. And the last one doesn't belong because it's just different than the rest. So again, this is getting us ready to go ahead and look into exponents and things that we can and cannot do with them. So let's go ahead and turn to page 53 to 54. It starts on page 53 and then it goes to 54. I know that the number one, it says choose 6 of the following. We're actually going to go ahead and answer all of these. And the reason why is because we need some experience on exponents. So go ahead, and I know they're not in order, but go ahead and do A, E, and I. Those are the ones on the top. We're going to do the top row. Pause and answer those questions and then come back to me. All right, let's go ahead and answer these. So we can go ahead and say we have 7. 7's being repeated over and over and over and again. Notice how here there's 5 7's being multiplied. Here there are 6 7's being multiplied. And remember, when we have it multiplying like this, as far as the same base being multiplied, we can add those exponents together. So we're going to go 5 plus 6, remember? So then we have 6 to the 11th power. The next one, there's a couple ways we can actually go ahead and do this. Remember that when we're dividing and it's the same base, so we know this, it's 3 and 3, so we have the same base, we can go ahead and subtract off of those exponents. So we can have 3 minus 28. And 3 minus 28 is a negative, so we're going to have 3 raised to a negative 25 if we just subtract those exponents. Now remember, with our last one, there are a couple of ways we can actually go ahead and do this. We can either write down 7 to the second 3 times being multiplied, and we can add those together, which will be 7 to the 6th. Or remember, if it's power to a power, that's what this is called, power to a power, we can multiply those numbers and get the same thing. All right, let's go ahead and do the next group and see what we get. So go ahead and pause, answer those, and then come back to me. So on the first one, again, let's do the same thing. Notice how it's 3 is the base being multiplied over and over again. So we can say negative 3 plus 8, and we get a positive 5. So we can say 3 to the 5th. Another thing that we can think of, remember, in the last lesson, negative exponents, to make them positive, we have to put them on the bottom part. And we can have it as this way. Well, what does this really say? That means I have 8 3's on the top. 3, 4, 5, 6, 7, 8. I have 3 3's on the bottom. Remember, we can cross them out, and then how many do I have left over? 5. So again, this is kind of where the 3 to the 5th power comes from. If we do the same thing on the next one, as far as the negative exponents, I can say this is 1 over 2 to the 5th times 2 to the 4th. So that's really 2 to the 4th over 2 to the 5th. So we have 1, 2, 3, 4. 1, 2, 3, 4, 5. And we can cross them out. So then I have 1 over 2 left over, or it can be 2 to the negative 1 power. And then the last one, that we can do it a couple ways. We can either multiply the exponents together and get 4 to the negative 9th power, or I can have it as 1 over 4 to the 3rd raised to the 3rd power. So notice how as a negative exponent goes down on the bottom. I can write out 4 to the 3rd 3 times, and I can write those, add those exponents together, and it'll be 1 over 4 to the 9th. And remember that both of these mean the same thing in math. All right, here is our third group. We can do it the same way. And so notice how we have, I'm going to change my color. We have it as 2 to the negative 4, 2 to the negative 3. We can go ahead and add those numbers together and get 2 to the negative 7. Or we can write it as 1 over 2 to the 7th. The next one, so notice how this 6 to negative 8, that's unhappy. We can actually bring it up to the top. So we can say 6 to the 5th times 6 to the 8th. And we can go ahead and add those exponents together. 6 plus 5 is 13. We say 6 to the 13th. Or if we subtract those number, we would have 5 minus negative 8. That also makes that 6 to the 13th. And then as far as kind of walking through these ones, we can multiply those numbers together. So we can say negative 8 times negative 4. So negative 8 times a negative 4 is positive 32. So it's 2 to the 32nd power. If we want to kind of walk through it as far as negative exponents, I can write it first as 2 to the negative 8 to the positive 4th power. So notice how the positive 4, I moved it to the bottom, it being negative, and then this guy's still negative, so we're going to move him back to the positive. And we can say, oh, we really have 2 to the 8th to the 4th power, and then we know we can multiply those exponents again and get 2 to the 32nd power. Here is our last group, and so we have it as 6 over 5 to the 4th to the 5th. Again, we know when it's multiplying by that. Fractions have to have parentheses around them, and if they're sitting next to each other, they're multiplying, so we can add the exponents. So we can add those exponents together, and 4 plus 5 is 9. Let's look at the next one. Notice how both of these have negative exponents. So we can make it so that it's equal. We can put the 10 to the 20 on the top, 10 to the 12th on the bottom. We know that we can say 20 minus 12 and get 8. So our answer is 10 to the 8th power. Last one, we can either multiply our exponents together. So we're going to get 6 to the negative 15th power. Or we can have it as 1 over 6 to the positive 3rd raised to the 5th power. So that means I have 1 over 6 to the 3rd 5 times. I can add those together, put 1 over to the 15th power, and remember that both of these mean the same thing. So going into number 3, we're talking about the exponents, right? Negative exponents. Go ahead and write these with a positive exponent. So remember on A, we're going to have it as 1 over 2 to the positive 7th power. D, we're going to have it 1 over 4 to the 9th power. And yes, I know it says to choose 3 of them, but we're going to go ahead and do all of them, make sure that we understand and know how to do these. B, again, go ahead and write them with a positive exponent and then come back to me. B is going to be 1 over the 33 to the 23rd power. E is going to be 1 over 2 to the 32nd power. And again, we're going to go ahead and do these ones and then come back to me. C is 1 over 11 to the positive 8th power. And F is 1 over 8 to the positive 3rd power. So notice how we can just kind of work through all of these and we can figure out what all of these actually represent and how to go ahead and do them. Let's go ahead and do the same thing with number 4. We're going to go ahead and go through all of them to figure out what the answer would be. So here is A and D. So go ahead and answer those two and then come back to me. A is actually going to be a positive 1. If we actually write down 10 5s together, remember that 10 divided by 10 is technically a big 1. I'm going to do this in different colors. So notice how this is 1 times 1 times 1 times 1 times 1. So our answer is going to be just 1. Number 2, and remember that evaluate means to find the final answer to. So on number 2, if we go through it, we're going to have 5 times 5 on the top, 4 times 4 on the bottom. 5 times 5 is 25. 4 times 4 is 16. So we can have it as 25 over 16. We can also do it as the mixed fraction. I'm just going to leave it as an improper fraction. Here is B and E. Again, we're going to go ahead and evaluate. We're going to find the final answer to all of this. So go ahead and answer those and then come back to me. B is 2/3 times 2/3 times 2/3. So 2 times 2 is 4 times 2 is 8. 3 times 3 is 9 times 3 is 27. E, remember anything raised to the 0 power is 1. And then here is C and F. Go ahead and answer these and then come back to me. So on C, 2 to the 8th is going to stay on the top. 2 to the negative 8 is going to go on the bottom because we're going to make it a positive exponent. So remember, on the top, we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Same thing on the bottom. And if we divide all of these out, it's going to be a positive 1, just like the other ones with the 10 that we did before. On F, we're going to have 7 over 2. Multiply it out twice. 7 times 7 is 49. 2 times 2 is 4. So let's go ahead and look at this for a second. 2 to the third times 2 to the fifth equals 10 times 3 plus 2, or 10 to the fifth. Do you agree that this could actually be true? So let's kind of think about it for a second. Could it actually be true? Well, unfortunately, it is not. So we're going to go over some questions that kind of actually talk about this. So what I want you to do is go through numbers 1 through 5. I want you to answer these questions. And what you're going to do is you're going to say if they're true or false. And then if they're false, go ahead and change them so that we can actually make them so that are a true statement. So go ahead and answer these and then come back to me. All right, let's go ahead and go through these. So on number 1, we have 1/3 of the second, 1/3 of the fourth. Both of the bases are the same. So I'm going to have 1/3 to the sixth. This one is true. Let's go ahead and look at 3 to the second times 5 to the third. So is it 15 to the fifth? It is false. Remember that we can only have the same base to go ahead and make it so that it would be actually true. So this is actually false. We could actually change it so that it's 3 to the fifth times 5 to the fifth, and then that would equal 15 to the fifth. We're actually going to talk about this tomorrow, so just kind of take it how it is right now. Let's look at number 3. Number 3, 5 to the fourth plus 5 to the fifth is at 5 to the ninth. True or false? This one is also false. So how can we go ahead and change this? We could make it as 5 to the fourth. How do we rewrite this down correctly? We make it as 5 to the fourth times 5 to the fifth. That would equal 5 to the ninth. Let's look at number 4. 1/2 to the fourth times 10 to the third is at 5 to the seventh. This, how it is right now, is still, again, false. It's because of the bases kind of not being the same, or the exponents not being the same. If I did have it as 1/2 to the third times 10 to the third, we would get it as 5 to the third. So notice how all the bases are the same, but the bases are different, but the exponents are the same. Then we would have that final answer. Again, we're going to talk about this tomorrow. So don't, if you're not understanding right now, it's okay. And then number 5, 3 to the second times 5 to the second is 15 to the second. This is actually true. Notice how even though we have different bases, if our exponents are the same, then I can go ahead and multiply them. So let me kind of show you. So if we had it where it was 3 times 3, and then we have 5 times 5, I can actually put these together as 3 times 5, which is 15. 3 times 5, which is also 15, which equals 15 to the second. And then again, in our next lesson, in lesson 8, we're actually going to talk about this further. So today we're kind of talked about just different exponents as far as being if they were true or false. Notice how these exponents, we have 2 to the fifth, 2 to the third. If we have it this way, you have to add the exponent, so that's false. Here we're going to have subtract it, so it is true. And then this is also false just because these exponents are also different. So again, we can go ahead and see how to do exponents and how to work through those. Go ahead and turn back to page 129. Read the I can statements for lesson 7. So I can change an expression with a negative exponent into an equivalent expression with a positive exponent. And I can choose an appropriate exponent rule to rewrite an expression to have a single exponent. Go ahead and write yourself a second sentence on how you feel right now. And then go ahead and give yourself a number. 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. We are doing practice problems lesson 7 for today. So make sure you start those and get into Canvas and answer those. Have a great day. Thanks. Bye.